So today is going to be the last day before our test, and we're going to learn about proving formally with formal two-column proofs if two triangles are congruent. So everything that we've been marking, that we've been doing with our whiteboard practice and on our worksheets, anything that we've been marking, we now have to say why and write out why we mark those things. A reason that we're going to use a lot in these proofs is what does corresponding parts of congruent triangles are congruent mean? So let's break that down. Corresponding, remember, means matching. So matching parts of congruent triangles are congruent. Basically means exactly that. If you know that two triangles are congruent, then their corresponding angles and sides are congruent, or their matching angles and sides are congruent. So with formal proofs, we're going to be proving that two triangles are congruent, and then we're going to prove that their angles are also congruent. And the reason we'll do that is going to be called CPCTC. Corresponding parts of congruent triangles are congruent. So the next question is, when are we actually going to use CPCTC? And this will be in a proof, in a formal proof, after we've proven two triangles congruent by side, 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 angle, side, angle, side, angle, 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 side, or hypotenuse, leg. So now we're going to go ahead and do a two-column proof. So I'm going to have you copy the given, the picture, and we will provide you statements and reasons. So go ahead and pause the video, take a second to copy this down. And I'm going to go ahead and create my two-column proof. So we want our statements and our reasons on one side, or statements on the left side and reasons on the right. Okay, so let's look at the given. It says G is the midpoint of FH. And the reason that G is the midpoint of FH is because that's what was given to us. Now I'm just going to write that first given in the column because now I want to mark on my picture what that means. If G is the midpoint of FH, so here's FH, this whole thing here, then that means G is directly in the middle. And I would show that by putting hash marks on FG and GH. Now before, when we were doing whiteboard practice and worksheet practice and all that stuff, we would just mark it and move on. But now in a two-column formal proof, we need to mark it, and then we need to actually write down what it is that we marked. And we marked that FG was congruent to GH. And the reason we're allowed to mark that is because G is the midpoint of FH. That's what's called the definition of midpoint. Now I'm going to go ahead and put back in the rest of the information that they gave us. They said that EF was congruent to EH. And I'm going to mark that on my picture as well. So because I've already used one hash mark on FG and GH, I'm going to use 2 on EF and 2 on EH. And the reason I can mark that is because they told me to. It was a given. Now if you look at your picture, notice this guy here, EG, and I've always told you, mark your shared side, always. Well, we have marked it, but we have to write down what we marked. Technically, if I were to separate these two triangles out, I have technically marked side EG congruent to side EG, which sounds redundant to say or write, but in a formal proof we have to include everything we've marked. So we marked side EG congruent to EG, and because we have exactly the same thing on both sides of our congruency symbol, we call this the reflexive property of congruency. And I'm just abbreviating it, reflexive property of congruency. Now, if you look at your picture, we have all three sides marked in each triangle. So now I can prove that these two triangles are congruent. So I can prove triangle FGH is congruent to triangle F to G to H, so I have to go HGE. So I've proven that these two triangles are congruent because if you notice, I have side, side, side. So now that I've proven that the two triangles are congruent, I can say that their corresponding parts are congruent. And in this case, they wanted us to prove angle 1 is congruent to angle 2. And if you notice, F and H are located in the same location of our congruency statement. So I can now say that angle 1 is congruent to angle 2, and the reason is called corresponding sides of congruent triangles are congruent. Sorry, I mean angles, because these are angles. So corresponding angles of congruent triangles are congruent, and you can abbreviate it like that. All right, so now we've proven what we were asked to prove. Let's move on to the second proof. Go ahead and take a second to draw this picture and copy the given. We'll go ahead and make another 2-column here where we have our statements in one. Okay, and the first thing I'm going to do is copy my given that M is the midpoint of PQ and RS. And the reason M is the midpoint of PQ and RS is because it was given. So now I need to look at my picture and look at what was given. M is the midpoint of PQ, so I would mark PM congruent to MQ. I would mark PM congruent to MQ. And M is the midpoint also of RS. So here's RS cut in half by the midpoint. So I marked RM congruent to MS. And the reason I did that is because I was told M was the midpoint. So the definition of midpoint says it cuts a segment into 2 congruent segments. I'm taking care of what information has been given to me. Now I look at my picture and I notice that I can mark my vertical angles congruent. And I have to name these angles using 3 points because if I just say angle M congruent to angle M, I don't know which M we're talking about. So because the 2 angles share a vertex, I have to name them with 3 points. So I'm going to say angle SMP. SMP is congruent to angle SMP RMQ. And that's the vertical angles theorem, or vertical angles are congruent, or as long as you say something about vertical angles. I'm going to say vertical angles are congruent. Okay, so now I've marked everything that I can mark. I have a side, an angle, and a side on each triangle. So that means I can prove that these 2 triangles are congruent by side, angle, side. So I'm going to do triangle SMP, not to be confused with angle SMP, triangle SMP congruent to triangle RMQ. And the reason these 2 triangles are congruent is the side angle side theorem. And now that I've proven these 2 triangles are congruent, I can prove that their corresponding sides are congruent. Side QR, which is the last and first letter, and side PS, which is the last and first letter. So because these triangles are congruent, I can say their corresponding sides are congruent, and QR and PS correspond with each other. So this is called corresponding sides of congruent triangles are congruent. And I abbreviated it here, but I have corresponding sides of congruent triangles are congruent. So we've proven what we've been asked to prove. Okay, and let's go ahead and do one more together. Go ahead and draw in our 2-column proof here. And go ahead and copy the picture and all this that is given. I'm going to go ahead and write down everything that's given because that's the easy part. And I also need to mark what it is that they gave us. They told us that KM is perpendicular to JL. So I need to mark that angle JKM is 90 degrees. So the measure of angle JKM is 90 degrees, and the measure of angle LKM is also 90 degrees. Angle LKM is also 90. And the reason I marked that is because that's the definition of perpendicular. I can abbreviate perpendicular. Perpendicular says that the 2 lines intersect at 90-degree angles. Okay, that takes care of the first part. The second part, JM is congruent to LM. That's already been marked for me. And the third part is angle JMK. Angle JMK, they tell us to mark it congruent to angle LMK, so congruent to angle LMK. So now I've marked everything that's been given, and I've added what additional information is needed. Now this time we're just trying to prove the triangles are congruent. We're not trying to prove that their corresponding sides are congruent or angles. So I have to somehow say that I can see it's getting me to angle, angle, side. That's basically where I'm going with this. But I can't just say count this as an angle yet. I have to establish that angle JKM is congruent to angle LKM, which clearly they are because they both equal 90 degrees, but I haven't gotten them to say that they are congruent. And the reason I can say they are congruent is because all right angles are congruent. So now I've gotten them to say that they are congruent, and now I can say that these two triangles are congruent. So triangle JKM is congruent to triangle LKM, and the reason is there's an angle, and a non-included side. So it's angle, angle, side, or you can put side angle, angle.